We are now going to learn about LCM, which is least common multiple. We're going to do a practice problem for LCM. So I'm taking from the fraction package, page 16, number 3. The LCM of 6 and 16 is, and choose from one of the multiple choice answers. If you know the answer off the top of your head, then great. I do want to now show you how to do it with the prime factorization method, just like we learned with GCF. So you can start on your own and then check your work with mine. So we're going to start with the prime factorization. Circle your prime numbers, put it into exponential form. So now we have to find the LCM. First, we're going to find what's in common, which is going to be our 2. But unlike with GCF, with LCM, we're going to use the higher exponent. So let's continue on the bottom. LCM is going to be 2 to the 4th. Not the 2, just 2 to the 4th. The other thing we do with LCM, which we didn't do with GCF, is we're going to use leftovers. That is not a math term, but that means that we're going to use numbers that we didn't use yet at all. And that's our 3. And so in addition to 2 to the 4th, I'm also going to multiply 3. Now that I've used all my numbers, I'm going to do the math. So 2 to the 4th is 16 times 3 is 48. And that's my leftovers. And the key with LCM is to make sure you find the common numbers and use the higher exponent, and afterwards use any numbers that you didn't use yet. And therefore, what's the answer? The answer is choice B, 48. Let's do another practice. Find the LCM of 20 and 175. Do it on your own, and then watch me. Circle your prime numbers. So now let's find the LCM. Let's look what we have in common. That would be our 5. And I'm going to use the higher exponent. So that's 5 to the 2nd power. So I'm not using my regular 5, and I'm using 5 to the 2nd power. Now I can multiply my leftovers, which is 2 to the 2nd power and 7. So I just want to show you this is our leftovers. And this is our common number, and it's the higher exponent. Now let's get our answer. So we have 5 to the 2nd power is 25 times 4 times 7. 25 times 4 is 100. 100 times 7 is 700. And that's our LCM. It's okay to get big numbers. Now we're going to see that LCM relates to fractions. It helps us find our least common denominator. So if I gave you an example problem, 3 over 16 plus 1 over 6. We know that the rule with adding fractions is you must have a common denominator. Here, I don't have a common denominator. So what am I going to do? I have to find the least common denominator. What's the least common denominator for 16 and 6? In order to figure it out, if you don't know it off the top of your head, you would find the least common multiple. Well, we did that already before. We found the least common multiple for 6 and 16 earlier, and we got that it's 48. And we used the method of prime factorization to figure it out. So if you're ever stuck and you can't find the least common multiple, yes, you can multiply 16 times 6, but you're going to get a really big number, and maybe you will reduce your fraction or you'll make a careless mistake. Here we see if you use the method that we learned, you can find the least common multiple, which is 48. So let's put this aside and let's add our fractions. So now we know our common denominator is 48. Let's review adding fractions. What I have to now change my numerator. So how did I jump from 6 to 48? I multiplied by 8 to get to 48. Whatever I do in my denominator, I do to my numerator. So 1 times 8 is 8. Same for the top. So how did I get from 16 to 48? 16 times 3 is 48. 3 times 3 is 9. Now I add 9 over 48 plus 8 over 48. When I do that, I'm going to get 17 over 48. And that's my answer, using least common multiple. For extra practice, please open up your fraction package, go to page 16, and do examples 2 and 7. Only numbers 2 and 7. The answer to number 2 is G. And the answer to number 7 is choice A, 30. Please make note of any questions you have, and tomorrow I will answer them in class.